Okay. Oh, some focus point of our history of parachute and recovery is the first point is in 1485 in the Atlantic Codex by Leonardo da Vinci, and through all the date that I'm jumping because we are a little late, and we can arrive to Captain Avery, and in 1963 the first powerful wing parachute, developed before by Francis Rogallo and then implemented by NASA. Oh yeah, wonderful thing. If you have some question, you can write down at the link below, and we'll see your question in our laptop and then answer at the end of the presentation. Okay. Here, Theodore Knack. Its name is a legend for everybody who works in recovery of a rocket and all the recover and bring the rocket down on the land. Okay, he was the main designer of the Mercury final parachute. This parachute is also used now to bring back the crew of ISS on Earth. And how you can read, it can be used till 1.5 Mach of speed. Okay, here is an image of the ISS return parachute, and this is Knack invention. Okay, I think it's your turn, Alo. Okay.
So let's talk about what we did in the previously rocket. In this image we can see our subsystem, because to use a parachute you should have the electronic device or something else which can open it. So we can see the ejection system, a strange system which tell us how to open the rocket, and later on we have the little one parachute called the pilot or drog parachute, and which is on this side. And after that, what is the strange things? It is a deployment bag, and inside the things are in yellow are not spaghetti, but are some special lines, so chores, and the same chord who are made in for the parachute, the main parachute, which is inside that bag. So, thank you. This is a very good picture because we knew that our systems are good and didn't fail. So we were happy, and we can see the drog, the main parachute, which was a cross parachute. I will later say because why cross for the form. And behind we can see the rocket R1X, which has 2 meters of length. So let's talk about what is a drog parachute. We see CAD or a 3D rendering, and we use it for the first descent phase of the rocket, and has the function to stabilization the descent for the first part. It works at 10 meters per second in terms of velocity. And later on we have a bigger parachute which has a big area, more or less 11 meters square, and this parachute, why the form, the shape is a cross? Because his function is to stabilize, okay, the descent more than the parachute before, and also s'mores the oscillation or the rocket and his movement. So, and this is the deployment bag where the main parachute is located. Usually, you can see the yellow one is made by nylon, the same material of the parachute, and the right one is made in polyester, so material which we use every day in our life. And you can see also in your left some tester for the traction test we did here in Politecnico in our laboratories, just to know if our materials has the properties of our industry where we both them. So let's talk about the subsystem which give me the possibility to open two of that parachutes. So we can see here a CO2 bottle which we use it in everyday life just to pull air in our bicycle. So it's very easy to find, and which is pulled on our needle by pressure valves, which is solenoid valves. And after that, we have the open of servo motor of the second one parachute by a servo motor. Sorry. So here you can see how it's the function of the ejection system. So.
Okay. Oh, here the main two subsystem of R2A, our new rocket, and are the nose cone expulsion and a thermal cutter on the right, the expulsion on the left. Okay. Okay, the ejection system is a spring-guided nose cone ejection system. You have, so you can see two configurations. In the left, the closed one, and in the right, the open one. So you can see that the spring, when released, have a force that can put out the nose cone away from the rocket. Okay, this is the main part of this system. This is a security hook, fuselage flange, spring, of course, and electric motor that can close or open this system. Okay, we can now see the cutting system. It is on the top of this drawing of 3D rendering. And this is a hot wire cutter that with the energy, yeah, heat energy can cut off the cord of the parachute. First drag, second drag, and then the ejection of our main wing. Okay, this is a render, of course, of the cutter system. You can see the first drag cutter, the second drag cutter. Inside each one there's a nichrome resistance that is the way because the cord can be broken. Okay.
All of that, those systems you can see here for the model, and if you want to see, you can come here later. So let's talk about parachute. So what kind of a parachute we choose for the next rocket Aero 2 Alpha. So we want to go up to almost 15,000 kilometers. So we want to have a soft landing phase of the system, and based on this thing, we project and design the system with 3 different parachutes. Why 3? Because the first one has to take all of the shock effort, and also to descend for the first 9,000 kilometers the rocket. And the second one drug is the cross. They are the same of the R1X recovery system. Why? Because we used it. We know that this system don't fail, I hope. And I know the properties of these kind of things, because in recovery system and in terms of parachutes, it's very difficult to test our things, because we have to go up and up, and we have to have a lot of money, and we should have also many different subsystems to test it, and so my aim is to don't give a failure, and I know that this kind of parachute tell me in this kind of descent phase I can don't have too much oscillations. Sorry for my English. And after that, but why I want to smooth our oscillation? Because I will use a different kind of parachute, which have also the lift component of the force. I will tell you later what is this kind of parachute. So maybe the aerospace engineer know the stall situation. So that the previous kind of parachute make me happy, because maybe I will haven't the stall. So to have a control guided parachute, I should have I should have electric part who give me the possibility to maneuver it. So I will show you different kind of parachutes which have also the lift component of the aerodynamical force, and not only the drag one. So I can guide it during the last part of the descent phase. Why a parachute, a guided parachute? Because I want to take my rockets nearest to the site of the launch. So it's very useful to have this kind of things, because the area of recovery, when you launch a rocket which reach 11,000 of kilometers, is very, very big. In fact, if we want to launch in Italy, it's better to have a recovery nearest to the launch site. So that's why. Now you can show them. You can see our model, because we did all of these things, and this is the model, and it's called the Rogallo wing, because it was studied by Francis Rogallo. This is the real model, which has 17 meters square of area, so very big. And these are our simulation by Envished model. So you can see same figures. So here you can see a very different graph, which give me the information how to strange things. It's better if you want to tell. Ask me later. And now we can see a little brief video. Okay, I did a mistake. Okay, check. È sparito. Not so good. Okay.
If you want to see, you can go on YouTube and it's better, I think. Okay. No. La vedi là, torno indietro. Okay. Thank you for paying attention.